Hello, welcome. NEET 2018 Physics Solutions recently held. Code GG. Question number 91. A tuning fork is used to produce resonance in a glass tube. The length of the air column in this tube can be adjusted by a variable piston at room temperature 27 degrees C. Note that data. Two successive resonances are produced at 20 centimeter and 73 centimeter. Okay. Of column length. If the frequency of the tuning fork is 320 Hertz, the velocity of sound in air at 27 degrees C is 4 options. 350 meter per second, 300 meter per second, 339 meter per second, 330 meter per second. See here, there is an experiment for 11th standard students in CBSE, resonance tube, wherein the students will find the frequency of, wherein the students will find the velocity of sound at room temperature. There is a method to be followed, procedure is there, and this is the direct application of the formula which you will use in that experiment. So extra derivations are not necessary. If you have done that experiment, you will know the formula, or even otherwise it's a general formula in a resonance apparatus how to find the velocity of sound at room temperature. The formula is this: V sub t is 2n into L2 minus L1. V subscript t, t is the room temperature which is 27 degrees C, n is the frequency of the tuning fork which is 320 Hertz, L2 is 73, L1 is 20. Simply we will have to plug in the value 2 into 320 into 73 minus 50, 73 minus 20, so 640 into 53. You can easily multiply this and you will get the answer close to this 339. I think answer will be 339.20. The answer is 339. Simply you will have to multiply, but note that this is in centimeter. So if you have to, what you will get will be in, the answer will be in centimeter per second. So divide by 100, you will get 339 meter per second. So this by 100 will give you 339 meter per second. So this would be the answer. Question number 92. The electrostatic force between the metal plates of an isolated parallel plate capacitor C having charge Q and area A is 4 options. Option 1, proportional to the square root of the distance between the plates. Option 2, inversely proportional to the distance between the plates. 3, linearly proportional to the distance between the plates. 4, independent of the distance between the plates. Okay, this is regarding the force between the metal plates. Very simple. The formula for the force between the plates: force half into Q into E. Q is the charge on the plate, E is the electric field somewhere here, anywhere in between the plates. But the question involves A, so you write Q as it is. For this E, Q by A epsilon naught. This is the formula for the electric field inside a parallel plate capacitor. Therefore, the answer is half into Q squared by A epsilon naught. You see, it depends inversely on the area but does not depend on the distance. Therefore, the fourth option is correct. What does the fourth option say? Independent of the distance between the plates. It does not depend on the distance. Of course, it depends on area for the given charge. You can see this isolated parallel plate capacitor. So, Q is constant. Of course, area A is given, but there is no D in the expression. So, fourth option is correct. Question 93. An electron falls from rest through a vertical distance h. In a uniform and vertically upward directed electric field E, the direction of the electric field is now reversed. Keeping its magnitude the same. A proton is allowed to fall from rest through the same vertical distance h. The time of fall of the electron in comparison to the time of fall of the proton is. 4 options. Option 1 10 times greater, option 2 equal, option 3 5 times greater, option 4 smaller. Basically, time of electron or time of fall of electron or time of fall of proton, whichever is greater. Basically, you have to find out that. Okay. So, here you can see the formula. The electron or the proton, they fall through the same height. Only thing, the electron, the direction of the electric field in the case of an electron and in the case of the proton will be different. Do you understand that? So, if always a positive charge will move in the direction of the electric field. So, if it is proton, you have to apply electric field down, because a positive charge will move along the direction of the electric field. If it is an electron, the electric field will be applied in the upward direction. Note that same magnitude for the electric fields, same height. You have to compare the time taken to travel the same height. So, use the formula h is equal to ut plus half a t squared, u 0. So, half a t squared. Half a acceleration is force by mass. Force is QE, mass is m, t square. Note in this case, h is same. Charge on the electron is numerically equal to charge on the proton. Q same. Magnitude of the electric field is same. So, t square by m is constant, because h is also constant. So, t square is proportional to m, which means greater the mass, greater the time. Greater the mass, greater the time. Mass of proton is greater, therefore time will be more for proton, therefore for electron it will be smaller. Therefore, the option 4 is correct. The answer is 4. You just discussed like this, don't have to derive anything very tedious in this case. So, t square is proportional to m. Don't have to consider t proportional to root m and all. Just say t square proportional to m means greater the mass, greater the time. Proton has got greater mass, it will take more time. Provided h is same, E is same, and of course charge on the proton is numerically equal to charge on the electron. So, t squared by m constant, t square is proportional to m. So, answer is the fourth option.